Good evening, my YouTube viewers. It's Crystal here. I'm just here because I want to do a code review on the spam email dataset. And I've got this spam email dataset from our repository where there's a lot of datasets stored in the R programming language. So basically, I have to use a different type of code to get the R dataset that I would normally use. So we're going to go over that with you. And this is a spam email dataset, and so you have to predict upon whether an email is spam or not. And so I created this program using Google Colab. Google Colab is a free online Jupyter notebook that that is hosted by Google. So that's the nice thing about Google Colab. So whenever I made my program, the first thing that you want to do is you want to import your libraries. So I imported Pandas as PD. So Pandas is a data manipulation library that enables you to create and maintain data frames. And whenever I was using Pandas, I got an error message saying that something was deprecated. So they told me to import Pandas util testing stm. So I did it. And then the next thing we imported was NumPy as NP. And NumPy enables you to do numerical calculations. It also enables you to create NumPy arrays. Then we imported math, which is an inbuilt function in Python, and it enables you to do mathematical computations that are not in the regular Python program. Then we imported Matplotlib, which is a graphics library that takes all the data points and plots them onto a graph. Then we imported Seaborn, which is a more high-level graphics library than Matplotlib, although it is written on the back of Matplotlib and enables you to do like statistical graphics. And we also imported Stats Models, and Stats Models is a statistical library. I was watching a video, or the beginning of a video, that was about 9 years old, and it said that Stats Models had originally been part of SciPy, but then it got big enough to where it became a library in its own right. But I didn't finish watching that video because it was a 3-hour video, and the video was like 9 years old, and the code in the video has changed, so it wasn't really worth me watching the video. I think that they should actually take that video off of YouTube because it's 9 years old, it's old technology, and it might have some benefit from nostalgic reasons, but I think everybody has more current versions of stat models now. So after I imported my libraries, I want to load my data set. I got my data set off of the from R, and then if you want to find it, if you click onto this link here, you can find that data set and lots of other data sets. So we'll just look here, and this is the GitHub repository that all those data sets are on, and so you can load the data set up from that GitHub repository. And so now that I've gone off of it, oh, that's not the right one. So we've loaded our data set. We didn't use Pandas to do it. We used Stats Models to load the data set. So data equals sm.datasets.getRDataset, and then spam, that's the name of the library, and DAAG was like the group that it was in. And so what you do is you print the data, and when you print the data, it tells you what is in that data set. So if you want to read the data set, it'll tell you what actually is in that data set. He said it was from Hewlett Packard Laboratory, so that's interesting. It says these data are available from the University of California at Irvine, repository of machine learning datasets and domain theories. The address is. So that's interesting. And so someone from Hewlett Packard had something to do with this as well. And then so what we want to do is we want to take this our data set and convert it to something that can be usable in Python. So data equals data. And that's just something that I just figured out. I just figured that out. I didn't see that written anywhere. I didn't see that in a YouTube video. I just guessed and I got it right. So after we take this data and we convert it to something that is usable in Python, what we want to do is we want to check for any null values, and we didn't have any null values. And then after we've checked for null values, we want to find all of the unique values. And so what we did was we used a for loop to go through every column, and when you go through every column, it will give you all the unique values of that column. So you can see all the unique values. And then so yes, no was either a yes or no. So we had to encode our target because the target was yes, no column. And so a Y is 1 and an N is 0. So you can see here that we've encoded our target using the replace function. And what we want to do is we want to analyze the target. So you can see that you have less ones than zeros, so there is a little bit of an imbalance. Now what we want to do is we want to check our heat map. And so you can see from the heat map that the columns don't have a very high correlation to each other. And then so what we do is we want to remove all the columns that have a high correlation, but since the columns don't have a high correlation to each other, none of the columns were dropped. So you have the same number of columns that you started with because it didn't drop any of the columns. But I did use this code on the breast cancer data set that had like 30 columns of data, and whenever I used that code on it, it dropped 10 columns. Because the thing is that you don't want to have columns that have a lot of redundant information, because what that does is that'll just generate noise into the system. So you want to try to get rid of all of the redundant columns that have a high correlation. So now what we're going to do is we're going to shuffle the data set. So from sklearn utils import shuffle, data equals shuffle data. So now you can see over here on the index that it's not in a sequential order any longer because we've shuffled it. And the reason why I shuffled it is because whenever I looked at the data set, you had like maybe all of the ones and then you had all of the zeros. And I thought, well, that's not going to work out very well. So I shuffled it so you'd have a mixture of ones and zeros in the data set or in the data frame. And so after we've shuffled the data set, then what we want to do is we want to define our X and our Y variables. So your Y variable is your dependent variable, and it's the yes/no column. And then after we've defined our Y variable, what you want to do is you want to drop the yes/no column, and then you define your X variable as being the data with the yes/no column dropped. So you can see your X variable here, which is also your independent variables. So you've got your data frame with the yes/no column dropped. Now after we have defined our X and our Y variables, what we want to do is we want to normalize the data. And when you normalize the data, what you're doing is you're taking the data and you're converting all of the values to a level between 0 and 1. And the reason why you do that is because the computer tends to do a better job of making predictions if the data is normalized. But what you're really supposed to do is you're supposed to run it with the data normalized, and run it with the data not normalized. And then you're supposed to select the method that gives you the highest level of accuracy. So now what I wanted to do is I wanted to split the data sets into training and validation sets. So we set our train size as being 90%. So X train equals X, the beginning to the train size. Y train is Y, the beginning to train size. X val is X, train size to the end. Y val is Y, train size to the end. And then you check your shape of all of these little data frames that you have made to ensure it's correct. So now what we've done is we've gone into stats models, and if you watched my last video I was using MN logic because I had a multinomial data set. Well, in this video we're just using logic, and the reason why is because we just got a binary data set, either 1 or a 0. So model equals sm.logic, y train, x train, and then we're going to pick it. And then summary equals model.summary, summary. So now you get a summary. And the summary gives you all this information, which I'm not a statistician, so I can't tell you everything, but it gives you a lot of great information that if you're a statistician, you can find it useful. One thing it does, it gives you your coefficient and your standard of error, your z value, your p is greater than z value, the 0.025 and 0.975, those are like your third standard deviation. So you've got your first standard deviation, and then your second standard deviation, and I think that is your third standard deviation. And then I just decided to look at the params as well. So we run up our params. I tried to look it up on the internet what a params is, and I didn't really get a lot, but I think it's something to do with parameters. But if you're a statistician, that'll mean something to you. And now what we're going to do is we're going to predict on the validation set. So ypred equals model.predict xval, ypred equals list map round ypred, and then you've got ypred. And so what you have is you have an array or a list of ones and zeros. And so what I wanted to do is I wanted to check the accuracy of the ypred versus the yval. And so I've created a for loop to do that. And this is my own little for loop that I made. And you had 82.4% accuracy on this emails using stats models. So you can also check your confusion, you can also check your confusion matrix. So you had 213 were zeros, and 55 of those were false negatives, and you had 167 ones, and 26 of those were false positives. So that's just telling you how many true values you had versus false negatives and false positives. And so I created a data frame. So this data frame will enable you to see which ones are correct, which ones were actually predicted, and which ones weren't. So that's a good thing. So what I wanted to do is I wanted to check it against sklearn. So the first thing we're going to do is we're just going to check our accuracy here. Accuracy was 82.4, and when we go to sklearn, the accuracy when we tested on the xval, the accuracy was 85. So the first thing that's saying is that your accuracy in sklearn is higher than the accuracy in stats models, and that's probably why you don't see a lot of stats models, because the accuracy in sklearn tends to be higher than it is in stats models. And so generally, whenever I'm looking at people's codes, it's generally going to be sklearn that they use. They don't use stats models very often, but you just use stats models as an exercise. But there are other things that you can do with stats models, such as time series. So you can't really do time series with sklearn unless you're going to do machine learning. So stats models is good for a time series, whereas sklearn isn't. And sklearn is good for machine learning, whereas stats model seems to perform less. It doesn't perform as well. So what we did was, because we used logit on stat models, I decided to use logistic regression in sklearn, and I got 82.39% when I trained and fitted the model on xtrain. But when I predicted on xfel, I got 85.4%. I checked my confusion matrix. I had 255 zeros with 13 being false negatives, and 139 ones with 54 being false positives. And then so we got our actual data frame where you can compare the actual values against the predicted values. So although the accuracy was in the 80s, it looks to me like sklearn outperforms stat models. And that's probably why when you're looking at code on the internet, you're going to see people using sklearn, because sklearn outperforms stat models. But as we carry on with our doing data sets using stats models, we'll find out more which one is more accurate, sklearn or stats models. But as I said before, sklearn is not really good for using time series, but stats models is. So people use stats models for time series. So I finished with this code review. So what I'm going to do is I'm going to go ahead and conclude this video, since we've done the code review already. I hope you got something meaningful out of this code review. If you like my video, please like, subscribe, and share. And I want to thank all of my subscribers for subscribing to my channel. And thank you so much for watching this video. I look forward to making more videos for you.